Hello, and welcome to Food Fads with me, Dr. Jessie King. This is the podcast where I go through the science behind your favorite food trends to help you understand whether they're legit or just straight up bullshit. Today, to kick off the first episode, we're talking about the official beverage of the basic bitch, kombucha. Kombucha originated in Asia with brewers in China, Korea, and eventually Japan, and was known as the tea of immortality. Nowadays, it's a popular drink in Western culture, primarily due to the abundance of claims made about its health benefits. And you can see this is definitely the marketing angle a lot of kombucha companies are taking. It's very common for kombucha and yoga to be coupled together for promotional events. So, in this episode, we're going to investigate whether any of the health claims of kombucha are actually supported by science. If you don't know what kombucha is, it's been very charmingly described as an acidic tea soup beverage. Kombucha is made by fermenting tea with what looks like a slab of putrid deli meat, otherwise known as a SCOBY, a symbiotic culture of bacteria and yeast. The fermentation times vary, but after an average of about 3 weeks, you get a fizzy, sweet, but slightly vinegar like drink. You can see why kombucha makers go so hard with the marketing, because the general description doesn't really lure people in. At this point, you can take out the SCOBY and reuse it to make more kombucha, and so the cycle continues. It's important to note, though, that not all kombucha is made equal. A lot of factors will contribute to the final product, like the type of tea used, the sugar content, the types of bacteria and yeast in the SCOBY can also vary, and kombucha can be fermented for different times and at different temperatures. So, the quote unquote nutritional profile of any kombucha is heavily dependent on how it is made. As it's derived from tea, there will obviously be a lot of compounds in the kombucha that would be found in the tea itself, but more are thought to arise from the fermentation process. These compounds that can have biological effects on the body are known as bioactives, and there's quite a range of bioactives in kombucha. You'll also find a variety of bacteria and yeasts in the drink from that SCOBY. Kombucha is one of the few drinks where it's actually considered good to see fuzzy brown strands floating around in it. It's like they're actively trying to put people off drinking it. One of the most common kinds of bacteria in kombucha are acetic acid bacteria, which are very aptly named because they do indeed convert sugars and ethanol into acetic acid. Acetic acid is what you find in vinegar, hence the characteristic acidity of kombucha. So there's a lot of things in kombucha, which means there's a lot of potential health benefits. The most common claims made are of anti-cancer, antioxidant, anti-diabetic, and probiotic effects. Some of the more alternative science websites might have more, but I want to stick to these four as each of these claims have different levels of validity. So let's go through them and look at where we can and can't draw some of these conclusions based on the current science. Let's first look at the claims of anti-cancer activity. This is a popular claim to throw around for pretty much any health food. Generally, websites claiming kombucha has anti-cancer activity or may have anti-cancer activity cite a research paper showing that kombucha can kill a particular type of cancer cell. These types of studies are what's known as in vitro studies. In vitro studies are biological studies that are performed outside of their normal biological context. You've probably heard of in vitro fertilization, in which eggs and sperm are combined outside of the body. Similarly, in vitro studies in science take cells from a living organism and experiments are conducted on that. For example, to see if a particular drug will have a desired effect on that specific cell type. There are actually a lot of different types of in vitro studies, and some becoming quite complex and can provide a lot of useful information. But generally, most scientists and most of the research papers out there are still using pretty basic in vitro experiments. When doing basic in vitro cancer studies, researchers will often use cancer cell lines, which are cells that were taken from a tumor of a specific patient, often decades ago. And these cells are considered to be immortal. Basically, if we give them the right nutrients and growth conditions in the lab, they will continue to grow and divide indefinitely. This is a great way to test how new drugs might affect cancer cells and look for drug candidates to follow up further, because it gives some information about how a chemical or a drug may affect the cell type in question without being influenced too much by other factors in the body. Because we can get some useful information about the potential effects of a new drug, and more importantly, because it's relatively cheap as far as biological experiments go, these kind of in vitro studies are often used as a starting point in scientific research. In the case of kombucha, there have been multiple studies conducted on cancer cell lines. As an example, there was a study conducted in a prostate cancer cell line known as PC3 cells. These PC3 cells were taken from a white 62-year-old male with grade 4 prostate cancer back in the 1970s. So these cells have been around for a long time. In the study, they used a kombucha extract prepared from black tea and tested how it affected the growth of these PC3 cells and what signaling pathways it might be affecting. Basically, what they found was that the kombucha extract could kill some of the PC3 cells, and they determined what changes were happening in the cell to cause this. But this is where it's important to understand the limitations of in vitro studies, as this affects the conclusions you can draw. When performing these in vitro experiments with cells, they're generally grown in what's called a monolayer, basically a flat single layer of cells on top of a specialized surface that helps them to adhere and grow, rather than the 3D structures these cells would form in the body. More generally, with in vitro studies, you're not taking into account the effect of other organs and chemical messengers traveling around the body, and you're not mimicking the pathway a drug has to travel to reach the desired cells. The cells are just not in their normal biological context. So any results obtained from these kind of in vitro studies only tell us what may happen to the cell type in question when that drug or chemical reaches these cells, but not what will happen and not how easy it will be for something to reach that cell target. Saying that something is an effective anti-cancer agent based on these kind of studies is like when my husband plays badminton against his workmates, beats all of them, and assumes he's just a really amazing badminton player. Like, yeah, you might be, but go beat someone who's nationally ranked and then come to that conclusion. So, treating prostate cancer cells with kombucha is not an accurate representation of how drinking kombucha will actually affect prostate cancer cells in the body. On a more practical note, they appear to only achieve about 50% cell death, meaning that at the highest concentration of kombucha they tested, only about half of the cancer cells were killed. I work with cancer cell lines in my PhD. I wasn't even doing cancer research. I was in the field of metabolic disease, but I still found drugs that caused cancer cell death. But these were never going to be pursued as anti-cancer drugs because pretty much any drug at a high enough concentration will cause some cancer cell death. For a promising anti-cancer effect, it's not just about killing cancer cells, because that itself is actually not that hard. The challenge is killing specifically the cancer cells and not killing any other cells in the body. So don't be fooled into thinking that just because something has been shown to kill cancer cells in vitro, that it will be an effective cancer treatment. There are other studies on the anti-cancer effect of kombucha which show similar results, but as far as I can see, nothing really above the in vitro level. And some of these studies are not new, so either the researchers were in no hurry to continue testing the amazing anti-cancer effects in further studies, or they did continue to test it and found, to no one's surprise, it didn't really do anything to treat cancer. Either way, at this point in time, there is no clinical evidence that kombucha has any significant anti cancer activity, so that's a false claim. That being said, it is very possible that kombucha could have other health benefits that prevent the development of certain cancers, but this is different from directly killing cancer cells. That brings us to the next claims about the antioxidant and probiotic effects of kombucha. And this is where we get to the next level of evidence regarding studies on the health effects of something. There's already a lot of information out there about antioxidants, but basically, we need antioxidants to counter the harmful effects of, shockingly, oxidants. Our body is continuously producing these oxidants, and if too many accumulate, then this results in a state of oxidative stress, which can end up causing damage to cells. Oxidative stress is not a disease in itself, but it is thought to be an underlying factor in pretty much every disease. Honestly, try and find a disease that hasn't been associated with oxidative stress. So it's important to ensure our body has an adequate antioxidant capacity. Generally speaking, the best way to actually do this is just eat a nutritious diet, but there's still a lot of interest in whether specific antioxidant rich foods will provide additional benefit, particularly in the gut. It makes sense that kombucha would have some level of antioxidant activity. It is made from tea, which is already known to contain antioxidants, particularly in the form of phenolic compounds. These are just a type of chemical which contain a particular moiety known as a phenol group, and this phenol group has been demonstrated to kind of mop up these oxidants before they cause damage to a cell. What's interesting about kombucha is that some studies have found kombucha to have greater antioxidant activity than the tea it is made from, as the fermentation process seems to help increase the phenolic content. The other health benefit I mentioned was that it contains probiotics. You've probably heard the recommendation to eat foods containing probiotics, things like yogurt, sauerkraut, and kimchi. Probiotics are live microorganisms that provide a beneficial health effect when consumed. Within our gut, we have trillions of microorganisms known as the gut microbiome. The more we learn about the microbiome, the more we realize its importance in human health. Last year, over 13,000 papers were published relating to the gut microbiome, exploring its significance in things like gut, metabolic, and brain health. It's also becoming increasingly clear that gut dysbiosis, that is, too little of the beneficial bacteria and too much of the harmful bacteria, can lead to all sorts of health conditions like inflammatory diseases in the gut, colorectal cancer, and metabolic diseases. So it's important to feed the good bacteria in our gut with foods that are called prebiotics, but there's also a huge interest in whether consuming beneficial bacteria can improve the overall balance as well, hence the interest in probiotics. The research is still a bit conflicting on how much benefit can actually come from adding probiotics to the diet and whether this changes with probiotic supplements versus probiotic foods, but some studies do suggest a noticeable beneficial effect. In kombucha, there are lots of different microorganisms, and as mentioned before, the exact composition is highly dependent on the starting material and the brewing conditions. But research has found that generally there's quite a range of bacteria and yeasts found in kombucha. For both the antioxidant and probiotic effects, there are what we call in vivo studies to support these ideas. Unlike in vitro studies performed outside the normal biological context, in vivo studies are done on whole animals, so treating an animal with a particular drug to test its effects. So it takes into account the whole body effect. Usually, when we say in vivo, we are referring to studies done on non-human animals, and mice and rats are by far the most common. And because oxidative stress and gut dysbiosis are thought to be underlying features of many different diseases, this also opens up the potential disease states that something with antioxidant or probiotic effects may be able to treat. When conducting in vivo studies, it's common for animals to be induced with a particular disease to create what we would call an animal model. Take, for instance, a study on the probiotic effects of kombucha in mice. This particular study was investigating whether kombucha could treat diabetes, so they used a diabetic mouse model. This involved feeding mice a high sugar and high fat diet for 4 weeks, and then the mice were given an injection of streptozocin. Streptozocin can be used as an anti-cancer agent, but it's very toxic to pancreatic islet cells, which is where insulin comes from. So injecting mice with streptozocin destroys these pancreatic islet cells, and that results in a diabetes-like phenotype. They then gave the mice kombucha for 4 weeks, or an appropriate control so that they could compare effects between groups. And they found that kombucha reduced blood glucose levels and improved insulin sensitivity in these diabetic mice. They also treated a group of these diabetic mice with metformin rather than kombucha. Metformin is a really effective anti-diabetic drug. It was kind of like the Regina George of the diabetes drugs until Ozempic upstaged it. And they found that kombucha had a pretty similar effect to metformin. So that helps to lend a bit of credibility to how effective kombucha was in this animal model. These beneficial effects were attributed to changes in the gut microbiota induced by kombucha. So they found more bacteria known to produce short chain fatty acids, especially acetic acid, and these are known to be beneficial for human health. So this led to an increased expression of genes that are involved in regulating glucose metabolism and insulin secretion and less inflammation in the gut. So this overall reduced that diabetic effect. Similarly, with the antioxidant effect, studies in animals have shown that kombucha can increase the antioxidant capacity. In a rat model of metabolic disease, kombucha was found to have a beneficial effect, decreasing blood glucose, cholesterol, and triglycerides after 14 days, and this was thought to be mediated by that antioxidant effect. So there can be studies showing the same overall effect, like improving metabolic health, but acting through different mechanisms, like a probiotic effect versus an antioxidant effect. In reality, it's likely that both of these mechanisms are actually at play. Generally, scientists have limited time and resources, money, so they have to hypothesize the particular pathway they want to explore in a study. So just because one study attributed kombucha's benefit to an antioxidant effect, that doesn't mean the probiotic effect wasn't happening. It's more likely that they just didn't test that aspect. The general conclusions from animal studies are that kombucha may be able to treat or help manage metabolic diseases like diabetes, high cholesterol, and fatty liver. So, animal models can be useful. They're clearly a step up from simple in vitro studies as they take into account the whole organism, but it's still important to understand their limitations. Remember that the mouse model of diabetes involved inducing this diabetic state with a drug. The way type 2 diabetes develops in humans is really complex. We're still trying to work out exactly how it happens, but it occurs over many, many years, and there are thought to be numerous underlying factors. More importantly, and this is not a particularly astute observation, humans are different to other animals. Sure, there are a lot of aspects of our physiology that we share with other animals, but there are also a lot of differences. We humans generally love chocolate and can consume it safely, but to dogs it's poisonous. There was a drug released in 1999 called Vioxx, which appeared perfectly safe in animals, but turned out to have significant cardiovascular risks in humans. It's actually estimated to have led to heart attacks in 88,000 people, and the drug had to be withdrawn because of this. So there's no guarantee that the results from an in vivo animal study will translate to humans. You may have also picked up that these studies involve giving kombucha to the animals daily. I mean, I long for the day where I'm earning enough that I can afford to buy kombucha on a daily basis. But in this economy, it's a luxury, so most people will only be consuming the occasional kombucha. So these animal models are by no means perfect or give a definite answer about how something will affect human health. The only way to actually be sure about these effects is by testing it in humans in what we call clinical trials. As far as I can see, there's only one human trial done on kombucha. This came out earlier this year, so it's very recent. And in the study, they were investigating how kombucha affected glycemic response, so looking at blood glucose levels after a meal, and also insulin levels. So this is along the lines of an anti-diabetic effect, but it's a bit more relevant for the prevention and management of type 2 diabetes rather than an actual treatment. For this study, they used 11 participants, which is pretty small as far as human studies go, but this isn't really surprising given that it seems to be the first trial on kombucha. So they had 4 males and 7 females, all of whom were healthy and metabolically normal. To conduct the experiment, they had each participant eat a very gourmet, carbohydrate rich meal consisting of rice, peas, and soy sauce, and had them consume a beverage along with this meal. So it was either soda water, diet lemonade, or kombucha. They did this on 3 separate occasions, so each participant had every beverage meal combination. And the researchers were taking blood samples every 15 minutes to determine the levels of glucose and insulin in the blood. So from this, they could draw these curves to show the glucose and insulin responses for participants. If you don't know, ideally you want your glucose levels to not spike too much. Of course, they will increase following a meal as glucose gets into your blood, but generally the smaller the increase, the better. So rather than the big ups and downs of a roller coaster, you just want your blood sugar to be chilling on a kiddie carousel ride. Despite the kombucha containing 3 more grams of carbohydrates than the other 2 beverages, its consumption with the test meal actually led to a slower increase in blood glucose levels compared to the responses seen when consuming the other beverages, which would be considered an improved glycemic response. A similar pattern was observed with the insulin responses as well. So, when drinking kombucha, these levels didn't reach as high a peak as they did for the other drinks, and they reached their peak about 15 minutes later. So that's actually quite a cool effect. It suggests that kombucha could help to slow the absorption of glucose into the blood, so you wouldn't be putting as much demand on your body to bring those levels back to normal. Now, the exact reason behind this response is not clear. Unlike the previous in vivo studies we discussed, which showed potentially beneficial effects through an antioxidant or probiotic effect, the effects observed here occurred in a pretty short time frame. It was only 2 hours. So this suggests that kombucha is having a more direct effect on the digestion of carbohydrates and or the absorption of glucose. The authors of the paper noted that acidic beverages have been thought to slow starch digestion and absorption, but in the study, the diet lemonade was a similar acidity to that of the kombucha, and the diet lemonade had no effect on the glycemic index, so it's unlikely that the acidity of the kombucha was the main effector. Another possibility is that some of the microorganisms in the kombucha could have metabolized the glucose in the stomach, meaning there would just be less glucose available to absorb. Or it's possible that a component of the kombucha, such as a tannin, may have bound to the enzyme that breaks down carbohydrates, slowing the digestion of those carbohydrates, therefore slowing the glucose being absorbed into the blood. There is quite an interest in understanding how tannins and other polyphenols may slow the digestion and absorption of sugars. There have been some studies suggesting that tannins and tea polyphenols can inhibit that carbohydrate digesting enzyme, though it does seem to vary depending on the type of tannin. But a study comparing how water, tea, and lemon juice affected the glycemic index following bread consumption suggested that tea had no significant effect, but quite acidic lemon juice was able to slow glucose absorption, which is somewhat contrary to the study. In all likelihood, it's probably a combination of factors that affect the glycemic index, and it will likely vary between different types of kombucha depending on how they're made. As with pretty much every research paper in science, more studies will need to be done, but regardless, this is a really interesting finding. Research on kombucha is growing every year, so there will undoubtedly be more human trials published soon. And once we have multiple well-designed human trials showing similar results, then we can start making conclusions about the health benefits. There is another type of human data that we have on kombucha's effects, and these are case studies of toxicity. Case studies differ from clinical trials as they generally only report on a single instance where toxicity was observed. As any good scientist, or even an average scientist, will be able to tell you, anecdotal evidence is not evidence. The effect of kombucha on an individual is not a strong enough argument to conclude that the same thing will happen to anyone who drinks kombucha, but it is important to look for patterns in case studies to highlight potential risks. Generally speaking, kombucha is considered safe, but some health risks can occur if proper hygiene processes haven't been followed during the brewing process, and this can lead to contamination. So this is particularly a risk for home brewers. You also have to be careful with the container you use to brew kombucha. There was actually an incident where a married couple brewed kombucha in some kind of ceramic container that contained lead, and the acidity of the kombucha caused the lead to leach out, and they had to be treated for lead poisoning. So do be careful what you brew it in. Glass is generally considered the safest option. You might need to be cautious about drinking quite acidic kombucha regularly. There have been some severe cases of metabolic acidosis thought to be associated with kombucha drinking. For example, a case study reported in 2009 described a 22-year-old male who developed metabolic acidosis and renal failure soon after consuming a 1-liter bottle of kombucha. Now, this was shared with someone else. We don't actually know how much he drank, but thankfully these symptoms resolved in the hospital. The cause was never officially determined, but given that the symptoms occurred so quickly following the kombucha drinking and that they resolved once he stopped, this was thought to be a key player. Back in 1995 in a town in Iowa, a lot of people were making their own kombucha at home. 2 people from this town were drinking their homemade kombucha daily for about 2 months before they developed metabolic acidosis. Unfortunately, one woman died from this, and the other went into cardiac arrest but was thankfully able to be resuscitated. Again, the underlying cause was never officially confirmed, but both women were found to have made their kombucha with a SCOBY from the same parent's SCOBY, and as far as I can tell, that's the only thing linking these two. That being said, there were thought to be over 115 more people in the town that were making kombucha with the same type of SCOBY, and no other illnesses were reported from this. It is very possible that underlying conditions will play some part in determining whether kombucha has harmful effects on someone. Some people have had allergic reactions to kombucha. It's also been suggested that people with renal, pulmonary, or liver conditions or compromised immunity might need to avoid it. Of course, always check with your doctor if you're concerned about this. The one group who are advised to avoid kombucha are those who are pregnant. Due to the fermentation process, some alcohol is produced in the making of kombucha. Commercially produced kombucha generally has an alcohol content below 0.5%, and in New Zealand, to be considered a non-alcoholic beverage, the content has to be below 1.15%. However, in 2022, just last year, it was found that a New Zealand company had 3 kombucha products with alcohol contents ranging from 2.8 to 3.2%, which had to be recalled. So do avoid it if you are pregnant, but generally speaking, kombucha is considered pretty safe at a standard serving size of around 330 mils or 12 ounces, which seems to be the standard single serve glass bottle size. So, to sum up, there are a lot of studies talking about the potential health benefits kombucha may have, but to be sure about these, we need multiple, well designed clinical trials. What's funny, though not at all surprising, is that even though the health benefits of kombucha are yet to be definitively proven and thoroughly examined, there is a huge interest in enhancing the therapeutic potential of kombucha even further. A key way of doing this is to add other products to the starting material. For example, studies on the properties of kombucha made with soy, coffee, fruits, turmeric, lemon balm, herbs, spices, etc., have generally found promising activity in vitro, and this can include antihypertensive, anti-diabetic, anti-cancer, antioxidant, anti-inflammatory, antimicrobial effects. But like I said, this does not provide any certainty that the effect will actually happen in humans. So don't be fooled by papers saying that a compound or food has anti cancer activity based on whether it killed a cancer cell line in vitro. Don't believe that it has any kind of activity purely based on in vitro studies. Be better than that. Know that animal studies can potentially hint towards how something might act in humans, but we can't know for sure until we actually test it in a human. If you like kombucha and you're not pregnant, drink it. If you don't, say no to the acidic tea soup beverage and drink something else. Thank you so much for listening to Food Fads. If there's a food fad you would like me to discuss on this podcast, you can email me at foodfadspodcast@gmail.com. Thank you so much for listening. I hope you learned something new, and I'll catch you guys next time when we're going to be talking about the turmeric latte. Bah, 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 bah. Primarily due to the abundance of claims made about its health benefits. Oh, fuck's sake. Today, to kick off the... Hello! What is wrong with you, man? You're so upset about... I don't know what you're upset about. Okay. This is a popular claim to throw around quote-unquote nutritional Oh, for fuck's sake. And how it is made. No. It'll have to do. Thanks. Sure.